As you're no doubt aware, we flew on the Space Shuttle Discovery. This was the 13th flight of Discovery. Unlike a lot of previous flights, we had gentlemen's hours. We got up about 2 in the afternoon, had a quick breakfast, and then we went into the suiting room where we put on our pressure suits. And this was a final opportunity to check the suits out, make sure that everything was working, the communications, the cooling systems, and also the pressure system. You'll see here I'm being pumped up inside the suit just to make sure that it holds pressure, and then when we're satisfied that everything's working, we depart from crew quarters, board the crew van, which will take us the 5 miles or so it is out to the launch pad. We launched right at sunset. It's pretty quiet laying on your back there for about 3 hours, but eventually somebody says 10, 9, 8, 7, 6, and at about 6.5 seconds they light the main engines. The whole vehicle starts to rumble and shake. Count continues on down to 0, and at that point they blow the hold down bolts, ignite the solid rocket boosters, and you're on your way. If you look closely, you can see the shock waves in the exhaust of the main engines right here, but they're sort of overpowered by the plume from the solid rocket boosters. We do a roll right after we lift off from the tower to establish our launch inclination, which is just a fancy word for what direction we're going to head. And in our case, it was a 57-degree inclination, which put us right up the east coast of the United States. You can see the shock waves as we go through Mach 1 forming on the leading edges of the solid rocket boosters. That flash that you saw right there was just a reflection off of a cloud that we passed through. The solid rocket boosters burned for about 2 minutes and 11 seconds. During that period of time, it's a fairly violent ride is probably too strong a word, but there's a lot of shake, rattle, and roll going on. The end of 2 minutes and 11 seconds, their work is done. They burned about 2.6 million pounds worth of propellant. And so at that point, the boosters are jettisoned and are recovered via parachute approximately 100 miles downrange. And here you can see the solid boosters separating from the main stack. Meanwhile, the orbiter attached to the external tank continues to burn for another 6 minutes or so. And then at about 8 minutes and 35 seconds, the main engine shut down, and we were in space. You don't really have much time to enjoy the ride. You're just sort of hanging on for ascent. So when you get on orbit, it's the first opportunity you really have to look out the window, and the first words out of my mouth were amazement at just how high we were. Shortly after getting onto orbit, we opened up the payload bay doors, had our first opportunity to glimpse our primary payload, the UR's Upper Atmospheric Research Satellite. And here we're putting out the KU band antenna, which is one of the primary means that we use to communicate with the orbiter through the TDRS, or Tracking and Data Relay satellites that NASA uses to both track and communicate with the space shuttles. On day 2, we did a raising burn. We initially inserted into a circular 292-degree mile burn, and then we raised it up to 308. These pulses that you see flashing up here are the forward RCS jets that are pulsing to maintain attitude. The glow right here are the sustained firing of the jets that are actually doing the raising burn itself, or are pushing us up to a higher altitude. We spent months training, and it was sort of a giant pain always climbing up and down the ladder, getting from the middeck to the flight deck, but it gets a whole lot easier when we get into space. You just sort of float out of your seat and then just sort of float down the axis way down into the middeck. Getting around in zero gravity is a real treat.
This is a short clip of the electronic still camera, which we used extensively on orbit. It's quite simply a Nikon F4 modified not to use regular commercial film, but instead record the images as digital ones and zeros. It has a normal flash attachment on the top and can use any regular Nikon off-the-shelf lens. And we took about 240 pictures on orbit, downlinked about 200, and I understand about 25 were released to the press. And worked quite well.
We took a wide variety of other types of photographic equipment with us as well. You've seen some of the examples of the products of those. What we're working with now is the dual mount twin 70mm Hasselblad cameras, one with color IR film and one with visual film. We also use the same mount for putting polarization filters on to take advantage of the difference between polarized light that's reflected off the surface of the ocean.
We spent a lot of time taking pictures from space, but occasionally all the cameras were taken, and we had the opportunity just to look out the window. Here I'm using the stabilized binoculars, gyro-stabilized binoculars to watch Australia go by. Here we're just taking a quick trip across the northwest corner of Australia.
This gives you appreciation for how fast even from that altitude. This is pretty much just the camera being fixed, pointed out the window, taking whatever is floating by in the world below. And you can see not only the rate at which the Earth goes by, but also the detail that you can see. Another thing which always struck me going across Australia was the diversity of the color of the ground. You can see the very, very deep blue of the ocean, the vivid reds and bronzes in the soil, and in some cases an occasional lake goes by with a lighter color blue. We're finally crossing the continent and coming out the other side into the Pacific Ocean.
And as was mentioned earlier, Australia was one of the clearest places that we saw on Earth.
These next few scenes were taken on deployment day. I was primarily responsible for operating the arm, and Ken was my backup. Sam was in charge of our interface with the spacecraft. Jim kept an eye on the space shuttle, and J.O. with his rubber hose kept an eye on all of us. The unberthing and extraction of the UR's payload was actually quite straightforward. A series of commands were given the URs to transfer it to its own battery power source. And then we flew the arm down and grappled with a fixture on the UR spacecraft itself. That was a structural strong point right there. The arm flew quite smoothly. There was no problem at all. This is the ROEU, which is the big electrical plug between the orbiter and the UR spacecraft. Over this electrical plug go all the data and information on the spacecraft, as well as backup electrical power until UR's is on its own. This scene shows URs being gently lifted out of the payload bay. From our perspective, it went quite smoothly and was no problem. We moved the spacecraft from its berth position to its release position directly above the orbiter windows in about 9 to 10 minutes. As you can see, UR's is very colorful with all the gold foil and white Kapton protective coverings. It is not a sleek spacecraft by any means, but is extremely functional.
That spacecraft took up approximately half the payload bay in length and weighed about 15,000 pounds. It's interesting that the arm is capable of lifting that 15,000 pounds in space, and yet it's unable to lift its own weight in 1G.
This is a scene in the aft flight deck with Mark on the right side actually controlling the arm, me in the middle watching over him and checking all the other indications, and John on the left side ready to conduct the maneuvers away from the spacecraft once we were ready to maneuver away. Once the arm was in position right over our heads, first thing we did was to deploy the solar array, and you can see it starting to extend now. After the solar array is fully deployed, as you see in this scene, we then commanded the ground commanded the high-gain antenna, which is seen right at the very bottom, looks like a dish, into a series of commands which checked it out and made sure that it was going to be functional.
This scene shows the actual release of URs with the mechanical arm. The arm is being backed away from the spacecraft. Once we're well clear, on and turn it over to John, whose job it was to back us away.
Once we got well clear of the spacecraft with the arm, we put in about a 2 foot per second separation burn. It was a forward jet burn, so that caused the payload to actually come right over the cockpit in a fairly quick manner. And because we had released it at night, we were really afraid that we were going to immediately lose sight of the spacecraft, and in fact I did. However, we had one camcorder that was mounted in the overhead window that managed to keep sight of the payload for a little while as it gradually receded away and just disappeared into the inky black of night. The life of the URs, one of the instruments on board is cryogenically cooled, and it's limited to approximately 18 months to 2 years of lifetime. The rest of the instruments can continue on to collect data for a number of years in the future. In fact, they estimate that the fuel on board will allow most of the instruments on URs to continue to collect data about the upper atmosphere for 8 to 10 years. Again, as many of you probably know, the primary mission of the UR spacecraft is to study the upper atmosphere, and primarily to study the ozone layer and to see if we can't understand exactly what's happening to the ozone layer. And it's done by 10 different instruments that are mounted on that spacecraft that take a look at 3 areas: the chemistry of the atmosphere, the dynamics of the atmosphere, the intermixing of the winds between the lower and the upper atmosphere, and finally the total energy input to the atmosphere.
After we were safely away from the URs, we started to work some other experiments we had on board. This one happens to be the modular dynamic experiment called MODE. It was built and constructed by MIT with its own computer on board. The idea of MODE is to do testing on fluids on orbit, to see how fluids respond inside a container to different frequency and amplitude responses. This particular little vessel had silicon oil in it. Mark is trying to line the oil bubble at the bottom of the container so that when we excited it, we could look at the dynamics and interaction between the container walls and the surface tension. You had to be a little careful in maneuvering it around to keep that meniscus aligned, but on orbit it was much easier to do than it was here on the ground. We also had a very large structure that we were interested in. This structure is instrumented, hooked into the computer. It replicates a scale model of what we think the space station will look like, and we're interested in looking at the dynamics and the harmonics associated with a large structure and weightlessness. When it was completed, the structure was about 7 feet in length. We lightly tethered it on the middeck so that it wouldn't float away and contaminate the data. And then we ran a series of frequency sweeps across the structure to see what different harmonics would be excited by the actuator, which is on the bottom of the structure.
Yeah, as on orbit is down here, the day gradually comes to an end and it's time to go to bed. Here you can see Sam comfortably tucked away in his sleeping bag. Jim hasn't quite gotten to bed yet. Sometimes we were tethered out in the middle, and sometimes people slept against the walls.
Here you see me putting on a series of electrodes. This was a 24-hour hard halter. Took EKG data, 24 hours continuous, and monitored blood pressure. Took blood pressure measurements every 20 minutes, and most of this research is being done for the extended duration orbiter.
Morning started with the normal ritual of getting up and getting cleaned up. We used primarily electric razors to take care of the stubble problem, and that all worked quite well. After that, we generally would get ready to have our morning meal. We fixed a lot of the same kinds of food we have here on Earth, with scrambled eggs and sausage available. And the only other problem was trying to control some of this food. And as you can see, Sam has got a runaway shrimp right there, trying to control that beauty, and eventually gets it where it's supposed to go.
We were busy throughout the flight and didn't often have an opportunity to eat all together, but some of the evening meals, particularly towards the end of the mission, we did have an opportunity as a crew to all sit down and eat at one time. Generally, breakfast and or lunch were sort of grabbed as time was available, and we tended to eat individually or perhaps just snack rather than sit down to a full meal. Periodically, I think the ground was curious as to what was going on and would try and spy on us, but taking control of some of the aft cameras and shining them towards the cockpit. We mentioned early on that most of the northern hemisphere was in darkness when we were up there. Here was one of the, because of that, we had the opportunity to see the northern lights or the auroras up there. Very spectacular. Generally tended to be centered around the northeastern Canada, around the Hudson Bay area. Although this is a black and white camera to take advantage of its low light capabilities, the aurora itself, as you saw or may know, is a bluish green color. Occasionally you'll get some other colors, blues and reds in there.
Here's another view of the ice pack with some of the islands there peeking out at the top. The opportunity to see a lot of that ice was really spectacular, first because it was in such a clear part of the world.
Did not look like a good place to vacation, by the way.
However, the air was clear.
I thought that the opportunity to take pictures and use all those cameras was one of the greatest thrills of being in space flight. And as John mentioned, a lot of times we were actually able to see lights at night in the detail. That is the Nile Delta.
That's the city of Cairo right there at the top, and then you just follow the Nile River on down here, and it literally is a river of light at night. The Sahara on either side, there's nothing, and then but where there's water, there's population. The lights right up here are just the edge of the Red Sea. And this river, the Nile River, just continues right on down with the population showing there at night until you get to the Aswan Dam, and then it just stops abruptly. These are the Galapagos Islands. You notice the tips of the cones of volcanoes sticking up through the clouds. This was the granddaddy of all the cameras we carried on board. This was the Linhof. Each negative there is about 5 inches square. One of the more spectacular things that we saw while we were up there was a night pass. We saw it on almost every rev over the United States that we passed over. Here you see Chicago coming into view. We're traveling from over Chicago down towards Miami, and we're looking out towards the southwest. Here we have St. Louis, Kansas City over here, Dallas, and Houston all in view at the same time. And we have Memphis. And Mark, correct me if I'm wrong, you're from the Midwest, but I believe this is Indianapolis here.
That's right. Followed by Louisville and then Cincinnati in the lower left corner.
It was very surprising to me to be able to see the detail of cities at night like that, and to actually, if you look closely, you can see the highway system connecting them. Occasionally, right in the middle of the screen, you'll see a giant thunderstorm and lightning show going off.
Being up at 300 miles is truly incredible with just the amount of the Earth that you can see. It's very, very impressive.
Again, you can see the LEM there and the atmosphere extending above the surface of the Earth itself, and there's a glow here that will gradually get more pronounced, and that's the moon set.
We're coming up on the east coast of the United States, but up in the upper part of the screen you can see the coast of the Gulf of Mexico from Houston going eastward toward New Orleans and then further down toward the Florida Peninsula.
I believe this is Atlanta coming into view here.
In the lower left-hand corner, you can see some of those major highway systems strung out from some of the larger cities up north.
should begin to see the recognizable peninsula of Florida showing up here, begin to appear right up in this area right here.
Really was spectacular to be able to see at night, looking across the whole front of the orbiter from one window to the other, sometimes almost coast to coast.
Here we have the city of Charleston. You're starting to see the Florida Peninsula now, the city of Jacksonville, Florida. Tampa, St. Pete area is starting to come into view here now, and then it will be connected to Orlando. And it's almost surprising to us, but it's almost totally cut Florida in half here with population and the lights string almost all the way across the peninsula right now. This is Daytona Beach, the area of Cocoa Beach right here, and the launch pad where we left a couple of days before is located right in here.
If you watch closely, you'll see what we think is a meteorite coming in right over Orlando.
To me, that was one of the most spectacular scenes and unexpected, was to be able to look down and see shooting stars or meteorites coming in underneath of you into the atmosphere, and you could follow them from the time they started to glow all the way till the time they burned up.
And finally, the tip of Florida in the Miami-Fort Lauderdale area right here. And there was a lot of thunderstorm activity down off the coast here, probably centered pretty well over Cuba.
In the upper right-hand corner is, in fact, the moon coming down. These are low-light level television capable to see that sort of thing.
Well, unfortunately, all good things come to an end. And the setting sun sort of symbolized that it was time to go home. As on the opposite of when we get on orbit, one of the first things we do is open up the payload bay doors. One of the last things we do is close the payload bay doors in preparation for coming home. A very empty payload bay.
But that's good, because that means a successful mission.
Here I am doing the final portion of getting suited up here, putting my helmet on, my pressure suit that we wear for launch and entry. And now you can begin to see the glow of the ionized air over the windows. We started out, did the deorbit burn over Africa, came all the way across the Indian Ocean, across the Pacific, and landed at Edwards Air Force Base. 4 of us were up on the flight deck, and for entry, Sam was down in the middeck. Here you can start to see the recombining of the plasma that surrounds the orbiter on reentry, and it recombines up on top of the orbiter. And although it looks like it might be the tip of the tail, this is actually just a very hot gas that recombines on top as we plunge down into the atmosphere. You're starting to see, if you look at this card, you can see a little bit of shaking going on as we went through Mach 14, or 14 times the speed of sound. Then you can see a little bit of the boundary layer being tripped here by the windows, and this white spidery almost looked like a St. Elmo's fire dancing on the windows. Here were the long-range cameras from Vandenberg, IR cameras taking pictures of us as we came in over Southern California. And you can start to see the delta shape of the orbiter. Again, another IR shot taken from the ground at Edwards Air Force Base as we make our final descent into the runway. And then coming through the bright lights, the xenon lights that we use to illuminate the runway, we touch down and roll out about 9,000 feet to a safe and conclusion to a very successful mission. And after 5 days, 8 hours and 28 minutes and 2.2 million miles, the trip was over.